The legendary ninth planet has been found. Not long ago, an article published on the preprint website ARCF caught the attention of the astronomy community. Researchers reported a potential sighting of the ninth planet in two sets of infrared satellite images taken 23 years apart. In fact, over 100 years ago, shortly after the discovery of Neptune, astronomers noticed that its orbit deviated from theoretical predictions. This suggested that something else was influencing its movement. Sure enough, in 1930, Pluto, considered the ninth planet at the time, was discovered. However, Pluto was too small to explain Neptune's orbital anomalies. There must be something beyond Pluto. As a result, astronomers began searching for the solar system's 10th planet. This led to two significant events. One was in 2006, when Pluto was reclassified as a dwarf planet, bringing the solar system back to having just 8 planets. The so-called 10th planet then became known as the ninth planet. Sometimes you might even come across the term Planet X. This term comes from the proposed name of the 10th planet, as X in Roman numerals represents 10, and in mathematics, X often represents an unknown variable. So whether it's referred to as the ninth planet or Planet X, they actually point to the same object. The other key event happened after the discovery of the asteroid Sedna. Many strange small celestial bodies were found beyond Neptune. These objects resemble comets and asteroids, but have very unusual orbits. For example, Sedna has a perihelion of 76 astronomical units, AU, and an aphelion of 937 AU, about 12 times further apart. Such elongated orbits don't seem like they were naturally formed, but rather like they were flung away by some force. Moreover, these bodies' orbits all tilt in the same direction, with the perihelion and aphelion aligned almost exactly. There are other peculiarities too, such as these objects avoiding Neptune's orbit and having strange orbital inclinations. To explain these phenomena, astronomers have proposed 3 hypotheses. They formed randomly, but the probability of this is extremely low, only 0.007%. Therefore, this explanation is hard to believe. The observations are biased due to a selection effect, meaning that not all objects in that region have such orbits, but our observational methods and conditions can only detect these specific types. This has a hint of the anthropic principle, but is still unlikely, with a probability of just 0.2%. The gravitational influence of an unknown body beyond Neptune is causing these anomalies. For this hypothesis to hold, the object would need to meet 2 criteria. It should be massive, at least 5 to 10 times the mass of Earth, and its orbit should be large enough and opposite in direction to those of the small bodies. Based on this, the object, if it exists, would be at least 500 to 700 AU away, many times farther than the Kuiper belt. At such a distance, the Sun would appear as nothing more than a faint speck of light. This vast distance makes it extremely difficult for existing telescopes to detect the object, or even impossible. So what can we do? The solution is simple. Although observing reflected sunlight is impractical, we can try to detect its infrared radiation. Even cold objects emit some heat, especially large planets that haven't cooled internally and thus continually radiate energy. If the ninth planet really exists, it should be visible in the infrared spectrum. However, infrared light is absorbed by Earth's atmosphere, so astronomers rely on space-based telescopes to observe it. In 2022, a group of astronomers analyzed data from 2 infrared satellites to look for clues. The satellites, launched at different times, provided data from the 1980s with a 10-month mission and from 2006 with a 5-year mission. Why compare data from satellites 23 years apart? Because, as mentioned, if the ninth planet exists, its orbit would be enormous, taking thousands of years to complete one orbit around the Sun. This means any movement would be incredibly slow, shifting only about 3 arcminutes per year. Therefore, a long observation period is necessary to detect such small changes. After analyzing thousands of AU in data and narrowing down hundreds of potential heat sources, the team found nothing. But just recently, another group of astronomers made a surprising discovery based on the same data. They identified pairs of light spots in the data. After ruling out known sources like stars and other inconsistencies, they found 13 potential targets. Through further analysis, they concluded that one pair of light spots, though located in different positions 23 years apart, likely represented the same moving source. The direction and distance of this movement matched the predicted orbit of the ninth planet. In addition to these two photos, the researchers found more evidence. 3 images were taken of the same position on different days in June 2006. The first images showed no light sources, but 6 months later, the satellite detected the same source at 2 different times. The location of the light source matched the predicted path of the ninth planet. These findings present the most compelling evidence yet for the existence of the ninth planet. Based on this, the researchers hypothesized that if the light source is indeed a planet, it is likely an ice giant, with a mass of around 7 to 17 times that of Earth. This would make it similar to Uranus or Neptune. However, the current data is still insufficient to definitively confirm the existence of the ninth planet. After all, we still don't know its full orbit, and recently discovered dwarf planet candidates like 2017 of 201 don't show any gathering effects in their orbits. This means that either the candidate will be ejected from the solar system by the ninth planet in the next 10 million years, or its orbit will completely rule out the existence of the ninth planet. Regardless, later this year, the Rubin Observatory in Chile will begin scanning the southern hemisphere for the next decade. Researchers believe that if the ninth planet exists, this observatory could be the key to finding it. If we can determine its orbit through observation, humanity might relive the historical moment of discovering Neptune.